Hello and welcome. In this video I will be presenting my level, which showcases various mathematical methods of movement, including linear interpolation and methods of curves, both of which use a custom math library and a custom easings library. When you are loaded into the scene, you will first notice the sign on your right. The text's colour will lerp between blue and transparent. You will also notice you are holding a robot with a black screen with some text. Pressing E will lerp the screen's colour to a new texture of a face, and the button on top will lerp down. Turning on the robot allows you to interact with objects in the scene by clicking with the mouse. Clicking on an object that is moving using the lerp script will change the text on the screen. The text will also lerp to fade in and out using the lerp of the object clicked. You will also notice this button here that says Launch Missile. Pressing this button will play a sound effect, activate a missile particle, and shake the screen. This is done by randomly generating a new end position for the camera to lerp to. It does this every 0.2 seconds to simulate a shake. Going up this platform that is being lerped up and down will bring you into the main room. On our right we will see a reactor full of balls that are bouncing using rigid bodies and a bouncy physics material. Next to it is this danger reading. This is using a hinge joint which is constantly flickering. These are both done by adding force to the object constantly. The ball script will find all of the game objects with the tag ball, and it will loop through each of them to add force. In the middle of this room is a cube which is being lerped in a few different ways. We can see that the position, rotation, scale and colour are all being affected. Clicking on this control panel will lerp the camera's movement and unhide the mouse. From this panel we can directly affect the cube using these UI elements, including position, rotation, scale and colour. We can also affect the duration so that it takes longer to complete the lerp. We can even affect the easing that the cube is using. There is also a screen which uses a camera that is outputting to a rendered texture. This is so we can see the changes happening to the cube in real time. This is done by checking the tag of the object clicked on. If it is the control panel tag, it will start this coroutine with the panel and a true boolean passed in as a parameter. Different states are affected by this boolean within the IE enumerator. This is so that this same function can be called to do the opposite, which will return the camera to its original position. There are these very simple functions within the lerping script itself. These can be called publicly, which can be used by the UI elements. This will just change the booleans whenever the toggles are changed. It will also set the duration to the slider's value and change the ease based on the drop-down choice. On the left of the room, there are two cubes that are being moved in a curve. The one on the left is using a Bezier curve and the one on the right uses a cardinal spline. Once again, we can interact with the control panel to alter how these cubes move. Both of these equations are contained in my custom math library. The Bezier works by lerping between the start and curve point and lerping between the end and curve point. It will then lerp between these 2 points and return that value. The cardinal spline also has a start, end point, and a point that the line will curve towards. It will also have a float for the weight of the pull towards the third point. Depending on how far through the equation the cube is, the weight will be affected using these tangents and these calculations here. My custom math library also contains a few different methods for lerps. As you can see, this utilizes method overloading so that I can lerp floats, vector 2s, vector 3s, or vector 4s. It also contains structs. These structs contain start and end values, which are necessary for making lerps happen. As you can see, we have a few different structs. This one using curves, giving you a starting position, an end position, a curve position, and a float to affect the tightness of the curve. My custom easings library contains quite a lot of different easings. These are just floats that will be returned as calculations. It'll perform the calculation based on the parameters that are passed through. The lerping script starts by creating 4 structs from the math library. It creates one for position, rotation, scale, and colour. These all contain start and end values, which can be changed in the inspector. It then initializes these values. These are the values that are affected by the lerp. It also has these variables which affect the duration and whether the individual components can be affected by the lerp. There is also an enum full of the different types of easings that are used. This function down here will have the float time passed through as a parameter. It will then check which easing is selected and perform the easing on the time for that specific easing. This is used in the main lerp function. It lerps these values using the lerp function in my maths library. Once the lerp is finished, it sets should loop to true. This is used in update, so it will switch the start and end values of the lerp whenever the lerp finishes. Pressing escape at any time will close the application.